So let me start with the problem. Every team that writes automated UI tests hits the same way. The app changes a little, a button gets rid, and suddenly your tests go right, even though nothing is actually. It is exhausting, and it is the number one reason teams give up on test automation. Self-healing was supposed to fix that. The test notices the change and patches itself, and it does. But it quietly created a worse problem. If the thing that changed is a real bug, a self-healing test just patches around it, turns green, and ships the bug in. The test fixed itself and hid the problem. So I built SelfHeal QA. It is an autonomous testing agent that runs on UiPath. It heals the tests that are only brittle and refuses to heal the ones hiding. Let me show you both, because that difference is the whole point. Here I am giving the agent two things: a code change and a one plain English sentence describing what should work. A returning user logs in and sees the welcome message. No test scripts, just plain English. Watch the first decision it makes on its own. Before running anything, it looks at what I changed and works out which tests that change could actually affect. So it runs just the one relevant suite, not all four. That matters because rerunning everything on every little change is what makes test suites painfully slow. Now, it writes the test, runs it in a real browser, and a step fails. The login button's ID got renamed in the new code. Here is the healing part. It reads the live page, finds that same button under its new name, rewrites the test to point at it, and runs it again. And then green. It correctly read that as a flaky locator. The button moved, but the feature still works. So it just fixed the test and moved on. That is the tedious maintenance that normally eats a QA engineer's whole morning, done in seconds by itself. Now I'm running the same exact test, but this time I have made the login genuinely broken. And here is the interesting part on the surface. It looks like the identical failure. And you'll see in a second. Same red step. A normal self-healer could not tell the difference. It would just patch around it and let the broken login ship. Watch what self-heal does. There it is. It refuses to heal. It looked at the failure, recognized this is not a moved button. It is a real regression, and made the call. Do not heal this. Instead, it files a defect in UiPath Test Manager so human knows that knowing when not to act is the entire idea. Heal the harmless stuff, raise the alarm on the dangerous stuff. And so, and none of this is a mock-up. It is all real inside UiPath Test Manager. So here I'm going to hit a refresh. And here you will see the agent's run history. And notice the names. Each run labels itself. This one self-healed, pass. This one real bug, defect filed. And you'll see that in a second. But here you see passed, one, failed one. And we'll go into the execution. And it'll always be like that. Green for the ones it fixed, red for the bug it caught. You can read exactly what the agent did at a glance. And here I'll open the red real bug run. And here you'll see the source says third party. That means the agent wrote this into Test Manager, not a real person. And top right, it filed, which you'll go into. It filed a defect for that real bug. The full reasoning why it decided that is a real bug and refused to heal it, you just watched print live in the terminal, and it is written into the test case the agent created. This is exactly where a human fits in. You're not babysitting tests anymore. You just review the real bugs the agent surfaces. The routine work is automated. The judgment stays human. And now the fair question. The one a skeptical engineer asks immediately: how do I know it will not heal past the real bug and hide it? An agent that is confidently wrong is dangerous. So I built a benchmark to prove it. 16 labeled failures, and I deliberately included adversarial ones, cases designed to trick it. A real bug where the button still exists, a harmless change dressed up to look like an error, when it finishes, and there is the result. Across all 16, you'll see it never once healed a real bug, a 0% false negative rate, and a 100% accuracy. That is a number that makes this all very trustworthy, and the triage accuracy is 16 out of 16, so 100% across 16 labeled cases. And so I believe this is a really good test study, as we did hit 0% false negative rate. And then we go into how it's built. And for that, I made a public repo on GitHub. And we'll go a quick look under the hood. The whole thing runs as a UiPath-coded agent. And I'll show you in the README, as it's fairly easy to understand. The orchestration you just saw: select, generate, run, triage, heal, or file, report. And it is all displayed to Orchestrator, so it runs on the UI platform, not any script off to the side, and then automatically deploys to Orchestrator. It talks to Test Manager through the API, creating the test cases, the runs, and the defects, with Claude making the actual bug versus brittleness call. And one more thing, I built every line of this with Claude Code throughout UiPath for coding agents. And to sum it up, UiPath's autopilot heals tests, and SelfHeal QA heals them and knows when to stop. Because when he tests quietly, heals past the real bug, it never fails, so nobody ever sees it. And that is the most dangerous bug there is, the one your tests fix for you. Thank you for watching. Appreciate it.